In order to find the absolute extrema, you have to first derive this. You're going to find the absolute extrema on this interval and on this interval of this equation. So there's two problems, one equation. First thing is derive. Oh, do you guys understand this is 1/2 power, hopefully? So you have a 1/2 4 minus x squared to the negative 1/2 times the derivative of the inside is negative 2x. Now when we simplify that, we get, looks like the negative 2 is going to cancel with the 2, leaving you negative x on top. And on bottom it looks like you're going to have a square root of 4 minus x squared. That looks good. Okay. Now, next, don't we set this equal to 0? Because we have intervals here, correct? We set this equal to 0. So we have, when does negative x equal to 0? That's easy. And when do we have the square root of 4 minus x squared equal to 0? So we're going to do both. Well, the first one's what? Yeah. There's 1. On the second one, well, do you understand, to get rid of this, you square root, or you half power both sides? I love having equal to 0. It makes it so much easier. What's 0 to the 1/2? 0. Yes. Then I got to solve this, so I minus the 4 over. Uh-oh. Will I have imaginaries? No, because we forget to divide by the negative 1. And some of you will forget this, but your answer is plus or minus. Don't forget that. 2. Remember, when you square root both sides, you get plus or minus. So I have 3 possibilities of absolute extrema. Sorry, these are 3 critical numbers which you have to check, including the endpoints. Now, look at number 1 here, or A. Are our endpoints the critical numbers? Hey! So we check them anyway, so we can actually ignore these, can't we? And it's 0 inside of this interval. Yeah. So all we're going to do is f of negative 2, f of 0, and f of 2. Do you guys understand we go to the original functions, hopefully? So f of negative 2 is going to be the square root of 4 minus negative 2 squared, which looks like it's going to be 0. Not very high, but we'll see. Could be the highest still. Or low. What is it? We'll see. Next one is square root of 4 minus 0 squared, which is 2. And we have 4 minus 2 squared, which is also 0. So those are our 3 possibilities. Well, hopefully you know that one's the max. You probably should absolute max is 0, 2. Now what about the other 2? They're your actual absolute mins. They're both absolute mins because they're both exactly the same height. So those are, let's put them right here, negative 2 comma 0 and 2 comma 0. These are your absolute minimums. Okay. This one is 0 in the interval. No. Is negative 2 in the interval? No. Is 2 in the interval? No. Is anything in the interval? So none of our critical numbers are in the interval. This is kind of weird. So really all we check are the endpoints. But is this endpoint going to count if it's there? No, but do you need this endpoint to see which is highest, which is lowest? So basically all we're going to do is do f of 1 and f of 2. Now it's kind of dumb to check f of 2 because it doesn't count, but we have to use it to tell which of the two is higher. Because do you understand, between these two values, if there's no critical numbers, there's no point where it turns around. It's kind of back to the intermediate value theorem. Between those 2 points, there's no point of turnaround, so either one of those is the highest, one of those is the lowest. So when you plug in 1, well, the square root of 4 minus 1 squared, well, that looks like the square root of 3. And what did we say the square root of 2? Oh, here it is. Yay! 0. Right there. So which one is the, well, okay, starting over. This one isn't possible, but out of the two, this one would be your what? Minimum. This one would be your maximum, but does it have an absolute min? No, because it doesn't exist. It's a hole because that. So all we have is an absolute max at 1 square root 3. We have no absolute min because the minimum value does not exist. It's a hole. But we had to check it to see which of these two is the highest and lowest. Otherwise we couldn't tell which one. We knew this was one of them. We just didn't know which one until we checked both. And the last one. How do we solve this? You can use double angle, but here's how I would do it. Because what if this is 3? What if this is 8? What I would do is I'd replace this as cosine u equals 0. And what do I want to make u? 2x. So cosine u equals 0. And I make u 2x. Now could I solve this? When is cosine equal to 0? We have a whole bunch of answers. Well, I should have put an interval, but we're just going to give a handful of them. What would be the first one? The first time where cosine equals 0 is pi over 2. Then we have 3 pi over 2. And then can we just keep going? Both directions? Okay, depending on the interval. But that's u. How do I find x? Well, if u equals x, could I go back to this and just write 2x equals pi over 2? 2x equals 3 pi over 2. You see that? U equals 2x, right? These are your u values. Could you just go and put 2x instead of u, now solve for x? And you have your x values. It's kind of weird. This is the way I kind of do it. I mean, there's other ways of doing it. So for this one, what you hopefully realize for this one is if you divide by 2, you get x equals pi over 4. If you divide by 2 here, you get x equals 3 pi over 4. And could you keep doing that pattern? You could. You just got to realize this u equals 2x. You set the u and then you solve for x. It's an easier way of doing it. It's not the best way, but it is a way.